Okay, we're continuing our discussion on the application of integration as it relates to the demand and the supply curve. And we're trying to maximize social gain, or in this case, we've now worked through our problem down to part C. So this is a continuation where it says we're trying to find the price. So we're looking for a dollar amount where the producer cartel, which is somebody that will set the quantity, will maximize the producer surplus. Okay, so we're trying to maximize the producer surplus. So let's do that. Producer surplus. Okay. That is what we're trying to work with. So let's set ourselves up an equation. So at this point, we're not necessarily looking for the equilibrium point. We're not looking for the maximum social gain. And we're not given an actual value. We're just told to maximize the producer surplus. So let's just pick a random value. And let's make that value, in this case, X. We need a new name. Okay, we don't want to call it Q because that Q is already kind of taken. This is a specific value, but we don't know what it is. So if we set it at Q, we can come up here and we can talk about the actual price that would be charging people. So we've got a quantity that we're calling X, and we've got a price that we're charging people, which in this case for the demand would be D of X. So if we plug in X, we can actually charge D of X. So what does that mean? It means we need to come down here and we need to kind of mark this off. This is the price point we're talking about, and just because I put it somewhere doesn't mean it's that value. It's just a representation right now. So all of this is above the supply curve, so it is a gain for the supplier or the producer. So this up here is producer surplus. Okay, they're charging this high price based on the demand, but it's all extra money that the producer is making. So let's set up that equation. So if we talk about the area of the region we're looking at, it's running from 0 to what we're calling X. And we're trying to leave X open because we're trying to maximize, so we don't know what that value of X should be. So we're going to come back here and we're going to say we have this top curve, okay, which is the demand curve. So it is, it is 210 minus Q squared. And then we're going to subtract whatever this bottom curve is. And this bottom curve is going to be set by whatever X is. So that's going to be 10 plus X squared. Okay. So X is already set for the supply because the cartel has decided how many items they're going to make, but as far as the demand, that's kind of open because it's actually calculating the gain there. So let's kind of go here a little bit further. So let's clean this up. It's not the kind of cleanup that we're used to. So 0 to X, 210 minus 10 would be 200. Okay. And then we've got minus Q squared, and we have minus X squared. And we're going to integrate that in terms of Q. So the important thing to understand here is that if you integrate in terms of Q, Q is the only variable. So even though X is here, it's really just considered a number. So let's kind of move this up so that we can keep writing. So as we integrate, 200 is a constant, so it picks up Q. Negative Q squared, we'll use the reverse power rule, so I go up to Q cubed and divide by 3. And then since x squared is considered a number, it'll pick up a Q. And we're going to do that from 0 to x. Okay, so we're trying to find a value that will maximize the producer surplus. So we need an equation to start with that will work for that. Okay, so I'm going to move down a little bit and eventually we'll move back up. So here we'll plug in x. So we'll plug that in. We'll have 200x minus 1/3 x cubed. And if I plug in x over here, I'll have minus x cubed. And I'll have minus, and I'm going to let q equal 0. So it's going to be 0 minus 0 minus 0, which I can just cross out. So let's come back over here. Ooh, I need to be able to write this down. So what we've got here is an equation that calculates the producer surplus based off of this random variable x, which is a quantity, and it came up with the equation 200x minus 1/3 x, excuse me, let's go ahead and combine those. So we got minus 1/3 x and we've got minus 1x, excuse me, we have minus 1/3 x cubed minus x cubed, so that'll be minus 4/3 x cubed. And there'd be a plus c there, technically, when we do that. So what we got here is we've got something that goes for the producer surplus. So if we picked a value here, which is a quantity, and plugged it in, we could get the producer surplus. But we want to maximize that. So max, oh my. Let's just use a different color. Max producer surplus. So if we want the maximum, we will take the derivative. So that would give us 200 minus 4x squared. So derivative tells us the slope at any place, and we want the slope to go flat or to be 0 when we hit a high point. So remember that from the first half of the semester, that if you want a high point, that it would be where you have a horizontal tangent. So let's set this equal to 0. So we've got 200 minus 4x squared equal to 0. So we will now solve this equation. Is that 50? So technically we would get plus or minus the square root of 50. But for the application, that would be square root of 50, which is 5 square roots of 2. We can come up with that in the calculator, but we throw out the minus because quantity can't be negative. So if you kind of look back what we've done here with the producer surplus, we've set up the equation. Let's kind of go back with a nice little highlighter. We're trying to find the producer surplus, so we set up an equation, and then we want to integrate it, which actually gives us the equation we plug in the endpoints, which we've got one that is kind of held open because we don't know what it's going to be. So now we've got the actual equation that if we set up a quantity, it would give us the actual producer surplus. But what we want to do is we want to maximize that. So we find the derivative, we set it equal to 0, and we actually get our number. And I think there was one more question with this. Let's see. It says find the producer surplus at that price. So what we've done here is, let's just very quickly set it up. Let's use a different color. Quantity for producer surplus equals 5 square roots of 2. And let me put that in the calculator real quick. 5 times square root of 2. So that is approximately 7.07. So we would need about 7 items to maximize the producer surplus, but we were actually asked to find the actual producer surplus. So we'll go back to the formula that was up here. Let's go back to this formula, and we will plug in the 5 square roots of 2, or 7.07, and let's see, 200 times 7.07 minus 1/3 7.07 cubed. So in my calculator, I'm going to try that out. And if I did everything correctly, I get that the producer surplus is 1,500, excuse me, $1,531.79. Okay, that was interesting. Still learning how this thing works. But that would be that the most the producer could gain. So if we went back up to the graph, shifting this X right here, left to right, will change this region that I have shaded. But setting the X at 7.07 or about 7 will give us the most surplus, or the most area between the price point and this blue curve. All right, thank you.